right, so let's go ahead and review quadratic functions. So everything that we know so far. So remember, I gave you 4 different types to look at, right? I gave you the most basic standard form. Okay, what was standard form? Anybody? Ax squared plus bx plus c. Okay. What's another variation of that one? Y equals ax squared plus c. We also have y equals just ax squared. Okay, so the linear and the constant term are missing. And we also have vertex form. Okay, so remember vertex form is y equals a times the quantity x minus h squared plus k. All right, so these are the 4 forms that we've studied so far. Remember I told you that the first thing that you should always do when graphing quadratics is to go ahead and find the vertex of each. So how do I find the vertex of each one of these forms? So in standard form, does anybody remember how to do that? Okay, so we find the x coordinate by using negative b over 2 times a. We know that whatever value we get for that, we plug it back in for x, and then we find y. Okay, so I'm just going to write it as a function to represent that that's what we plug back in. Okay, so that is standard form. How do we find the vertex for when the linear term is missing? Anybody? Okay, so 0, comma c, very good. All right, so basic, right here, we know that the vertex is always at 0, comma 0. Remember, I want a coordinate, so tell me x and y. And when it's in vertex form, the vertex is h, comma k. Excellent. Okay, so let's review each one of these forms as far as finding the vertex. So if I gave you something that looks like this, y equals, let's just say, x squared plus 2x plus 3. Okay, what would be the first thing that I need to do to find the vertex? So I plug it into this formula. So I know that x equals negative 2 over 2 times what? 2 times 1. Okay, so our x coordinate in this case would be negative 1. Okay, remember that once we find the x value, we plug it back into the whole thing. So if x is negative 1, I'm going to go ahead and substitute that in. Okay, and see what my y coordinate is. So negative 1 squared, 2 times negative 1, plus 3. Okay, so y equals negative 1 plus 3, which is, all right. So my vertex would actually be what?
Negative 1, comma 2.
Okay, so what is the difference between y equals 3x squared and y equals negative 3x squared? What does it do to the graph? So this graph, you know, would be opening up. We're not actually graphing for accuracy. We just want to graph based on the behavior of the graph. And we know that this graph opens down. Okay? Let's also talk about what a does specifically. So a, okay, this variable here. Okay, so what is the difference between this graph and this graph? What does that number, the leading coefficient, what does this do to the graph? Anybody?
It makes it more narrow or wide.
Okay, so remember that when you have a number that's between 0 and 1, your graph is a wider graph. Okay, so if we were to graph this one and this one on the same graph, let's go ahead and do that now. Okay, we already know that both of these centers are where? Okay, so we know both of them are at 0, 0. So let's just use negative 1 and 1 for both. Okay, -1 squared is 1. 1 times a half is a half. Okay, plug in 1 for x. 1 squared is 1. 1 times a half is a half. Over here, -1 squared is 1. 1 times 2 is 2. 1 squared is 1. 1 times 2 is 2. All right, so my first graph at -1, I'm at a half. At 0, I'm at 0, and at 1, I'm also at a half. So this was, okay, the first one. The second one, I'll go ahead and graph in blue. At -1, we're at 2. Okay, the vertex was still at 0, 0, and 1, we're up at 2. Okay, so everybody should see that this graph, y equals 2x squared, is a stretched graph, remember vocabulary words, and y equals 1/2 x squared is more of a compressed graph. Okay, so instead of saying like wider or more narrow, we can say stretched and compressed. All right, any questions up until this point? Okay, so I'm going to break you up into groups, and you guys are going to present a problem to the class. I'll assign problems. So remember that everybody has to know how to
Now we can graph it, so go get another
understand and be guided to help, okay?
So it should be like y is greater than -4
Y is what? Write that down and then it should be the same
Do you get to maximum and minimum?
Yes, you need to give the maximum, minimum. You need to give all the components that we talked about.
Okay.
Is it a maximum or is it a minimum? Does everybody hear? What else? Green. Okay, because remember, I'm calling on each first randomly.
I don't like how it's there. They're already here. We're just rewriting the steps and then we already finished. We're just gonna graph it into that.
Was -3. The domain was all the numbers, and our range was y equals greater than or less than -3. Our axis of symmetry was 2.
Okay, when you say the axis of symmetry, how do we say the axis of symmetry is 2?
No.
We say it as an equation, so x equals 2. Okay, tell us something else that was not mentioned before. What else do we know about this graph?
It's opening up.
Okay, which means
Positive.
it's positive. How do we know if the graph is positive? What determines whether the graph opens up or down? What part of the equation tells us?
X.
Not the x, but the coefficient in front of the quadratic term, right? So if you look at your quadratic term, okay, x squared, in front of it is positive. That's what tells us it opens up. Okay, very good. Thank you, guys.